Hi, my name is Kris Applegate, and I'm one of the solution architects here in the Dell Technologies Customer Solution Centers. Here in the Solution Centers, we're constantly engaging with our Dell Technologies customers on behalf of account teams in order to demonstrate the value of our combined portfolio. In the global CSC labs, we have both equipment and personnel to engage with our customers around topics ranging from end user computing to servers, storage, networking, HPC, artificial intelligence and machine learning, and what we're talking about today, the VMware Cloud and Tanzu portfolio. Whether it's a demo like we're doing today, or a technical briefing, a whiteboarding session, or even hosting a POC, there's no charge for anything we do here in the CSC. Reach out to your Dell account teams to submit a request today. Today, we're going to talk about running and orchestrating containers on vSphere using Tanzu Basic and vSphere's networking. This is one of the many different ways that you can continue to introduce the capability to run modern cloud-native workloads that your users are demanding while keeping the familiar vSphere experience that you've developed skills around. Let's go ahead and take a look at one of our Tanzu Basic clusters here. Here you can see this looks like any other vSphere cluster that you're already used to dealing with. We use the same vSphere console, and I'm running virtual machines in here just like I would anything else. But what we've done is we've actually added on the Tanzu Basic capabilities that's going to allow us to run and orchestrate these new containers. So I first went up here to workload management. The first thing that you do is you build a cluster. Now, you'll be prompted for a little bit of information around specific IPs and vSphere distributed port groups, but these are the same types of constructs that you're already used to dealing with. These aren't monumental changes. You don't need to use VMware NSX at this stage. Once I specify a little bit of that information, it will actually go ahead and start installing and building what we're calling the supervisor cluster. This is actually what turns the vSphere nodes themselves into Kubernetes worker nodes. And then the next thing that happens after I build that underlying cluster is I can start to create namespaces. And these namespaces are the organizational units in which my assets will live. And so here you can see I have a single namespace carved out. When we go back here to hosts and clusters, you can see all of my namespaces listed. Here I have one namespace. The supervisor control plane virtual machines that are actually orchestrating my worker nodes that make up the Tanzu nodes. And then under this namespace, you can see I've created guest clusters. What we find is that most customers that start to introduce some form of Kubernetes solution, it's not about building a Kubernetes cluster, a single one. Right? What inevitably will happen is you'll build a large cluster and you'll put one application. And as that application starts to thrive and succeed, other people will want to start putting more applications and more services on that. However, they'll come at you with different requirements. Maybe it's a different version of Kubernetes. Maybe it's a different security profile. Maybe it's the ability to run privileged escalation on containers. These are cluster-wide settings. I don't want to have to set such a high-level feature just because I have one workload that requires it. So it's not that I needed a Kubernetes cluster. It's in fact that I needed Kubernetes clusters as a service. And that's where the idea of Tanzu comes in, and it allows you to provision these guest clusters. So here you can see I have 3 guest clusters, one called CI/CD, another development, and another production. And the amount of resources that I put into these can vary. Maybe if it's development, I don't need high levels of availability. Maybe in production, I want that level of high availability. You can see here that I can actually expand and see the individual nodes that make up this guest cluster. I can also go to the namespace here and I can get an overall view of these clusters. Now, take a look at the distribution and version. These are running different versions of Kubernetes. So I'm able to provide multiple virtual clusters using the same shared pool of resources. That's the differentiator. Clusters as a service, not individual clusters, each with their own orchestration and toolchain managed in a vacuum of each other. So how did I create workloads and start consuming the services of these guest clusters? More often than not, what's going to happen is the users and the developers are going to come to you. they're going to interface with this using either an API or the command line interface. So let's go ahead and do that. So here I have just a command line, and first thing I want to do is I want to go ahead and authenticate to the guest cluster. I'm going to go ahead and start consuming services out of that development guest cluster. So I've written a simple shell script that allows me to automate the attachment of that. And then I say I want inside namespace 1, I want to go ahead and talk to the development cluster. Once I provide my necessary credentials, here you can see, all right, you're ready to start consuming those services. Every command I type moving forward now is going to be as if I'm sitting in a room directly attached to just this guest cluster. If I type kubectl, which I've shortened here to just the letter K, if I say get nodes, you can see those exact control plane and worker nodes that we saw on the previous screen, but I'm interfacing with them through the native Kubernetes tools that I, as a developer, am already well and comfortable with using. So let's go ahead and create a workload on this. We have a sample workload that oftentimes we use here in the Customer Solution Center that's just a basic multi-container workload that's good at showing that we are properly configured a cluster and we can access it. Right? So I'm going to take that file, which here you can see is a manifest called yelb.yaml, and it contains all of the individual containers that are going to run, specifies the services and ports, etc. All is packaged up in this file. I'm going to take that file and I'm going to say, dear Kubernetes, go ahead and create everything you see in this file. When I do that, you can see a series of services and deployments with their necessary containers have already been created here. Now I can say, all right, Kubernetes, show me what services you've created. Well, here we are. Look at this one at the bottom, Yelb user interface. And you can see it has an external IP being provided by the load balancer that I've already configured as part of my Tanzu basic setup. In this case, I'm using the HA proxy open source load balancer. When I go ahead and interface with that API, you can see here's my application right now. This is a sample application that allows you to vote on healthy food recommendations. Right? As I click in here, you'll see that my session persists and it's tracking vote counts. And as I refresh, you'll see that the load balancer is properly moving this amongst different individual containers. So I know that this is properly working. This is a great test to make sure that everything is set up correctly. So this is how I can start consuming general purpose Kubernetes services out of one of these guest clusters. But how did I get to this guest cluster itself? Well, the cool thing about the Tanzu setup is that a guest cluster is just another primitive inside Kubernetes. What I can do is I can actually go ahead and set my context, my focus from being this guest cluster up to being the namespace. And now I can go ahead and document the cluster that I want to configure in a configuration file. Exactly like we did with that example workload, I can now do that same thing with a guest cluster. So here's that configuration file. Let's take a look at it. So obviously I can specify a name here. We'll call this one demo. I want it to live inside the same namespace as before. You can see I can choose what version of Kubernetes I want this to run. And then I can start configuring the size of my control plane, the number of nodes from an availability standpoint, the amount of resources that I want to commit to it. And the scale here starts with whether I want either a soft resource allocation called best effort, or instead of the words best effort here, I could put guaranteed, which is a firm resource allocation. Then the last thing you see there is a t-shirt size, small, extra small, medium, large, 8XL. And those correlate to the amount of vCPUs and memory and local storage that each one of these nodes would have. So here, this is just going to be a demonstration. I'm fine with no availability when it comes to the control plane, and 3 worker nodes is going to be just fine. I've also specified in here that should anybody need some level of persistent storage, I'm going to go ahead and satisfy that with my vSAN data store that's underlying the Tanzu basic cluster. Now, all Tanzu is doing is talking to vSphere and using those storage policies. This could be vSAN, it could be a Power Store. It could be some other storage on the back half of vSphere. It doesn't matter to Tanzu Basic. The vSAN one is very effective because the nodes already have the storage in it. It's going to be highly performant, and I don't need additional infrastructure outside the nodes themselves. So once I take this file, and exactly in the same way that I created that sample application, I do the same thing with this. I say, "Dear Kubernetes, please create everything you see in this file." The difference is, in this file, it's the description of a guest cluster. He's ingested that. And now when I flip back over here to my user interface, look at that. You can see it created a new guest cluster heading called demo. And then in a matter of seconds here, it'll start to provision the control plane node. There you can see it just kicked off. And then once that's up, then it'll add in the worker nodes and deliver me in a couple of minutes a fully functional guest cluster running on this same shared infrastructure as the rest of it. So this idea of the rapid ability to stand up this capacity as you continue to grow, add more lines of business, add more separate applications, as this continues to grow, you're going to start wanting to grow your utilization of the Tanzu portfolio. Right? This is great to get conversations started, but inevitably then it comes, maybe I want to start getting further introspection down into what's running on that cluster. I can start to bring in assets of the Tanzu portfolio like Wavefront that will actually allow me to go in and introspect into these nodes and see what my utilization is, what pods are taking up the most amount of my CPU, memory, etc. The same thing goes with the cluster provisioning process. Maybe I want to not have to use the pure API or command line. Maybe I want to give my users some sort of interface for building policies and requesting guest clusters. This is something Tanzu Mission Control does very well. This offering, well, it's running out in the cloud. It's actually in control of my on-premises vSphere cluster that's running Tanzu Basic. I can go in here and say, I'd like to create a new cluster, please. These are all the same steps that I had in that configuration file, but presented in a GUI. And this might make it more palatable to certain users, as well as for greater levels of integration with other tools. Here I'm going to say, go ahead and let's take a look at the namespace 1 inside my Tanzu Basic cluster. I can create another demonstration cluster. And here I can start to configure what version of Kubernetes do you want to run. You can see I have a host of choices ranging from 116 to 117 and 118. I can specify internal IP ranges. I can specify what persistent storage I want, just like in the last one where I had vSAN storage. I can then go down here and size in the same manner that I did in that configuration file, the control plane. Do you want a single node or do you want this highly available? What type of instance do you want? How much resources do you want to commit? Here's those t-shirt sizes and whether I want best effort or guaranteed. Right? I'm going to go ahead and do similar to what we did of a best effort small with a vSAN storage policy backing it. And now here's where I actually specify my worker nodes. I can specify that these maybe I want to be a little bit larger, and maybe I want 5 of them. When I hit create cluster here, the Tanzu Mission Control is actually talking down to my on-premises Tanzu Basic cluster, and you'll see here in a couple minutes, it'll fire a job exactly in the same way that the the command line driven interface does, where it'll start creating this new cluster. The idea here is to continue to give options. You can see there's demo 2 just fired, but to continue to give you options to explore what this portfolio looks like and how you can start using it today. So we here in the CSC would be happy to discuss this further or to demonstrate a whole host of other technologies that we have here at Dell Technologies. Please go ahead and reach out to your account teams and get something scheduled today. Thank you very much for your time.